Today we shall discuss some problems from the first chapter, that is vectors. The first question is, prove that A cross B cross C is equal to B into A dot C minus C into A dot B. Okay, we have already studied this equation and this is called the BAC CAB rule, or you can say the back cap rule. Okay, B into A dot C minus C into A dot B. So we have to prove this equation. Okay, so we will take the left side, that is A cross B cross C. Okay, now that is equal to X cap, then Y cap, Z cap, then A cross B cross C. So you can write it as AX, AY, AZ, then the components of B cross C. So what is B cross C? B cross C equal to X cap, Y cap, Z cap, Bx, By, Bz, Cx, Cy, Zz, isn't it? So what is the X component? X component of B cross C, that is equal to By Cz minus Cy Bz, isn't it? So that is By Cz minus Cy Bz. Okay. And what is the Y component? Y component is that is minus, isn't it? Minus Y cap into Bx Cz minus Cx Bz. Okay, so I will write the second name first to make it plus positive. Okay, so that is second component is Y cap into minus Y cap into this one minus this one. Okay, so you can write it as Bz Cx Cx minus Bx Cz. Cx minus Bx Cz. Okay. Now the Z component is Bx Cy minus By Cx minus By Cx. Okay. Now you can expand this one, and what is the first one? That is X cap into Ax into, sorry, that is X cap into, this should be removed, that is Ay into Bx Cy minus By Cx minus Az into this one Bz Cx minus Bx Cz. Okay, so that is the first component. Okay, the X cap into Ay into Bx Cy minus By Cx minus Az into Bz Cx minus Bx Cz. Okay, that is the X component. Now plus we can write similarly the Y component and the Z component also. Okay, so the same way you can write it. I am not writing that. Plus Z cap into the third component. Okay, now you expand the first one, that is this one. Okay, I am erasing it. So this is equal to, you write X cap into Ay Bx Cy minus Ay by cx minus az bz cx, isn't it? Az bz cx minus az plus az bx cz. Okay. Plus, okay. So you have the remaining terms are also there. Plus y cap into this one plus z cap into the next term. Okay. Now you take the right side. That is b into a dot c minus c into a dot b. Okay. So you can expand this one and you can write the x component. Okay. And you will get this expression. And like this, you can prove that you have the y component and z component will also be the same. So you take the first one. So what is the first one? B into a dot c. So what is a dot c? A dot c is ax cx plus ay cy plus az cz. Okay. And a dot b is ax bx plus ay by plus az bz. Okay. So what is b into a dot c? That is equal to, so b means x cap into bx plus y cap into by plus z cap into bz. Okay. So this one will be, so you can write it as the x component for this one. So that is bx into what is a dot c? A dot c is ax cx plus ay cy plus az cz. Okay. So that is into x cap. Okay. So that is the x component for the first term, isn't it? So what will be the second term? by into again ax bx plus ax cx plus ay cy plus az cz into y cap. What is the z component? That is equal to bz into again bz into this one. Okay. Into z cap and so on. Okay. So I am writing the x component only. Okay. Now what about the x component of this one? That is minus cx into ax bx plus ay by plus az bz. Okay. Az bz into x cap. Okay. Then plus y cap terms are there, plus the y cap terms are there, and the z cap terms are there. Here also you have the x cap, the y cap terms are there, plus the z cap terms are there. Okay. So you take only the x part, that is x component. So you can combine this. So x cap into, what is this? You can expand this. Ax, you can write it as ax bx into cx. Okay. Ax bx cx, then plus bx into ay cy plus bx into az cz. Okay. Into x cap. Then expand this one. This will be equal to minus cx ax bx, then minus cx into ay by minus Cx into Az Bz into x cap, isn't it? Okay. We can put the x cap as common for all these. There is a Cx into Az into Bz. Okay. So we can put it like this. Okay, right. Now, see, sum of this one will cancel, isn't it? That is Ax, Bx, Cx is there. And from this one also, you have this particular term, minus Cx into Ax into Bx. So, these two terms will cancel. Okay. Now, you can see that this is equal to Bx into Ay into Cy, Bx into Az into Cz, minus Cx into Ay into By, minus Cx into Iz into Bz. Okay. Now, you can compare this one. Okay, this is equal to Ay into Bx into Cy. That is Ay into Bx into Cy minus Ay By Cx minus Ay By Cx. Okay. Now minus Iz Bz Cx minus Az Bz Cx plus Az Bx Cz plus Az Bx Zz. Okay. So these two, you can see that these two are the same. See, remember, we have proved it for the x component only. So you can do the same for the y component and the z component. Okay. So eventually you can see that all these are equal, and we can write A cross B cross C equal to B into A dot C minus C into A dot B. Okay. So that is the first problem. Okay. Now we will go to the second one. So second question is, prove that A cross B cross C plus B cross C cross A plus C cross A cross B, that is equal to C cross A cross B is equal to 0. So this is the second question. So A cross B cross C plus B cross C cross A plus C cross A cross B, that is equal to 0. So this is cyclic of always. See, you can A, B, C, then B, C, A, C, A, B. That is cyclic, isn't it? A, B, C. A, B, C. Okay. So A cross B cross C, B cross C cross A, then C cross A cross B. Okay. So this will be the direction. Okay, that will be cyclic. Now, see, you can use the equation in the previous, what we have proved in the previous problem. That is A cross B cross C equal to, what is A cross B cross C? That is a BAC minus CAB. So this is the equation we have proved in the previous section. Okay. So we can apply this one to all these three. See, you have to remember the order. That's the only thing. Okay. So if you are putting the value, or you are using it for B cross C cross A, in place of B we have C, in place of C we have A, and that is the only thing. Okay. So you can write this as A cross B cross C plus B cross C cross A plus C cross A cross B, that is equal to first one. First one is there, this same equation, that is B into A dot C minus C into A dot B. Okay. Now plus, what is second one? B cross C cross A. Okay. So that is equal to, that is the, in place of B we have C, the middle term, that is C into A cross B, sorry, A dot C. Okay, this is the equation. So we have, in place of B we have C. Okay, then we are using it, so this will be C into B dot A, isn't it? C into B dot A minus A into B dot C plus, and what about the third term? Third term is C into A cross B. So the middle term is A. Okay, so A into C dot B minus B into C dot B. Sorry, that is a B into C dot A. Okay. Now, say you go through it, you can see B into A dot C, and there is minus B into C dot A is here. Okay. So A dot C and C dot A are the same. Okay. So these two terms will cancel each other. Okay. Now, okay, so these two are gone. Now, what about the second term? C into A dot B minus C into A dot B. Here it is a plus C into B dot A and A dot B are the same. So these two will also go. Okay. Now you have two terms, minus A into B dot C, and here it is A into C dot B. Okay, B dot C and C dot C, B dot C and C dot B are the same. So these two will cancel, and so you have finally the value is equal to 0. Okay. So we have proved it. A cross B cross C plus B cross C cross A plus C cross A cross B is equal to 0. So that is the first part, and there is a second part for this one. That is, under what conditions does A cross B cross C equal to A cross B cross C? The question is, under what conditions A cross B cross C is equal to A cross B cross C. Okay. So we have changed the order. Okay. So under what conditions these two will be the same. Okay. Now you use this equation. So from this one you can write A cross B cross C. Then you take this second term to the right side. Okay. And keep this one, but the order is reversed. So you can write it as minus A cross B cross C. Okay. Minus A cross B cross C. That is equal to, you take this one to the right side, that is equal to minus B into C cross A. Okay. Now this is equal to B cross C cross A. So this is equal to minus into, you use the rule we have proved in the first problem, that is C into what is that? That is B dot C. The equation is, here write it, A cross B cross C is equal to B into A dot C minus C into A dot B. Okay. So this is the equation. A cross B cross C equal to B into A dot C minus C into A dot B. So using here we have, first is this one. So it is the center we have C. Instead of B we have C here. Okay. So C into A dot C. So in place of A we have B here, the first one. Then in place of the C we have A, that is B dot A. Then minus, next one is C. Okay, the third position, that is A into, okay, that is in place of C we have A into, that is in the A dot B, in place of A we have B. Okay, so that is equal to B dot C. Okay. Into B dot C. Okay. Now, see, our question is under what condition these two will be equal. These two will be equal means subtracting that one, this should be equal to 0. Okay. So this should be equal to 0 means that there are two conditions. From the first one, we can conclude that these two, this is a cross product, isn't it? So when will this become equal to 0? When C and A are parallel to each other. Okay. So the condition is that either A, C and A are parallel, or you can say anti-parallel. Okay. So in that condition, this term will be equal to 0. Okay. And from this second part, from this equation, from this side, you can write another condition, you can arrive at another conclusion that B dot A, B dot C, dot products are there. So here the condition is that B dot A must be equal to 0 and B dot C must be equal to 0. Then you can say this is equal to, or this one and this one are same. Okay, that is, they are equal. So the second one is that this term must be equal to 0 and this term must be equal to 0. So we can say B dot A equal to 0 and B dot C equal to 0 means B is, when is this dot product 0? When the angle is equal to 90 degree. Okay, B dot A equal to BA cos theta and cos 90 equal to 0. So B is perpendicular to A and C. Okay. So B is perpendicular to A and C. So if any of these conditions are satisfied, we can say that A cross B cross C equal to A cross B cross C. Okay. So this term will be, right side will be equal to 0. Okay. We'll go to the third problem, that is find the gradient of the function. Find the gradient of the function, that is function is given as f of x, y, z equal to e raised to x sin y log z. Okay, e raised to x sin y log z. So we have to find the gradient of this one. So what is gradient? Gradient is del f. Okay, that is equal to dou f by dou x into x cap plus dou f by dou y into y cap plus dou f by dou z into z cap. Okay, so this is the equation for the gradient. So you can write what is dou f by dou x into x cap. Okay, so this is the only term that depends upon x. Only term that depends upon y is sin y. Only term with the z variable is log z. Okay, so the first term will be e raised to x. Derivative with respect to x is again e raised to x itself. So e raised to x sin y log z into x cap plus dou f by dou y. So this is a term with respect to y. So sin y derivative will be cos y. So you can write it as e raised to x cos y log z into z cap plus the third term is dou f by dou z. The term is this one. So you can write it as e raised to x sin y into log z is 1 by z into z cap. Okay. So this is the gradient of the function f, where f is e raised to x sin y log z. Okay. So this is the answer. Now we will go to the fourth question. The question is, the height of a certain hill is given by hxy is equal to 10 into 2xy minus 3x square minus 4y square minus 18x then plus 28y plus 12. Okay. Now h is in feet. The unit of h is in feet, and x and y are in miles, and that are the x is the distance east of a particular place. Distance east. East of a particular place, and y is the distance north. Okay, that is the distance north of that particular place. Okay, so x and y are in miles. Okay, this is the problem from Grevy's textbook. That is why you can say if it is kilometer, you want, then x and y are kilometers. In the question it is given as the unit is in miles and h is in feet. Okay, now the question is, how high is the hill? How high is the hill? Okay, that means the height you have to work out. And second one, where is the top of the hill located? Where is the top of the hill located? Okay, that is the question. So first is how high, and also where is the top with respect to that particular place. Okay. So this is the question. Now to the first part, that is where is the top of the hill. Okay, and how high is the hill? So you know that suppose this is the hill, and then at the top you know that the slope is equal to 0, isn't it? At the maximum height, the slope will be equal to 0. So here you can take it as del h. Del h is the gradient, that is also the slope. So you take del h. See, x and y are the variables, so it is given in a single plane only. Okay, 2 dimensional. So del h is dou h by dou x into x cap plus dou h by dou y into y cap. Okay. So what is dou h by dou x? See, this is 10 is common factor here. So you can write it as 10 into dou h by dou x. So that is 2y minus dou h by dou x. So this is 6x. This is 0. This is minus 18. Then no x term are there. So this is into x cap plus second one with respect to y. 10 is there outside the common bracket. So this is 2x, isn't it? 2x, 0, minus 8y, then 0 plus 28 into y cap. Okay, so this is del h. Now we have seen that at the top we have del h should be equal to 0. So del h should be equal to 0. Equal to 0. That implies that this term must be equal to 0. So this is the x component and this is the y component. So this term must be equal to 0 and this term must also be equal to 0. So you can write 2y minus 6x minus 18 should be equal to 0 and 2x minus 8y plus 28 should be equal to 0 because these are the two separate components. Okay. Now you can simplify this one. See, there is 2x. You can multiply the second term with 3. So this will be 6x minus 24y and so on. Then you add these two and you can simplify. You will get the value of x and y. Okay. And the values that we will obtain is x is equal to minus 2 and y is equal to 3. So you can solve this and you will get these two values. Okay. Now x and y are the parameters which gives you the directions. So that is the position, isn't it? So what was y? Y is the distance to north of that particular place. So you can say y is equal to 3 means the hill is 3 kilometers. Okay, the unit here is miles. 3 miles to north. Okay, 3 miles north of that particular place. And what was x? X is the distance east. Okay, east of that particular place. So x is distance to that towards east. And now we have x is equal to minus 2. That means now the hill is placed towards west, isn't it? That is in the opposite direction because it is a minus 2. Okay, so the hill is placed 3 kilometers north and 2 kilometers west. Okay, because x is equal to, that is the position towards east. Okay, so 3 kilometers north and 2 kilometers west of that particular place. So that is the meaning of x and y. Now you can put the values of x and y in this equation. Okay, so we have h is equal to this one. Okay, so this will be h is equal to, you can put the values there. So h is equal to 10 into 2xy minus 3x square minus 4y square minus 18x plus 28y plus 12. Okay, so you put the values there. You will get the height of the hill. Okay, and the value you will obtain will be h is equal to the value obtained is a 720 feet. Okay, feet. Then also you can put there. You can put simply the values of x and y. You will get the value of this one also. H is equal to 720 feet. Okay, you can do that. Okay, now for that question there is another part. How steep is the slope at a point 1 mile north and 1 mile east? That is the third part. How steep? That means you have to calculate the slope. Okay. How steep is the slope at a point 1 mile north? That is equal to y is equal to 1. And also 1 mile east. That is x is equal to 1. Okay, x is the distance east. Okay. So y is equal to 1, x is equal to 1. Okay, so you have to find the value of the slope. How steep is the hill? So you have to find the value of del h. Okay. At y is equal to 1, x is equal to 1. Okay, I will erase that one. So what is del h? Del h is equal to 10 into 2 y minus 6x minus 18 into x cap, then plus that one will be 2x minus 8y plus 28 into y cap. Okay. Now put x is equal to 1 and y is equal to 1. And you will get the value, that is 10 into, you can put the values there, and what you will obtain will be, I am writing the answer only. So this is equal to 220 into, sorry, 10 into minus 22x plus 22y, minus 22x plus 22y. Put the values there, you will get this equation. Okay, or that is equal to 220 into minus x plus y. Okay, so okay. Now, what is the magnitude of this one? That is equal to, you can take square root of, this is x component and y component are there. So you can write it as minus 220x plus 220y. Okay, so if you take the modulus of that one, it will be 220 into square root of 1 plus 1. That is equal to 220 into root 2. Okay, so that will be the slope, or that is the slope of the hill at that particular position. Y is equal to 1 and x is equal to 1. Okay, and that value you will obtain will be approximately, the value will be equal to 311. That is equal to 311. You can say the unit is there, that is, this is the slope. Okay, that is dou h by dou x and dou h by dou y. So that will be feet per mile. That means per mile, this will be the slope. Okay, this is the steepness of the hill, 311 feet per mile. Okay. So we will continue with these problems in the next class.